All right, so last time we talked about inscribed angles, and one of the key things that was important about inscribed angles is understanding that they're angles that happen when the intersection between two chords essentially is on the circle. Okay, so the vertex of that angle was on the circle. Okay, so now we're going to look at okay, what happens when a secant and a tangent intersect on the circle, right? How's that going to be different? What's going to be different about it? And the answer is simply nothing. Okay, so there's a couple of reasons why that's true. Okay, so if I want to think about either of these two angles, right, on the side of this chord. Okay, so since DE we're going to say is right, tangent to circle A. Okay, we're going to assume that already, right? Which means that if I look at AC, right, AC is perpendicular to DE. That's what it means for it to be tangent, okay? Because AC is a radius, so all tangents are perpendicular to radii. And we also know that point C is called the point of tangency, okay? Now, when we're talking about secant and a tangent intersecting on the circle, the only place that they can actually intersect where it's on the circle is that point of tangency, okay? And so now there's lots of different ways that we can go about proving this and showing why this is true. But the very simple part is, if I look at this angle right here, okay, it coincides with this entire arc right here, okay? And if I look at this, let's get green. If I look at this entire angle here, it coincides with this arc right here. Now, if I added up both those arcs together, right, what would I get? 360, okay? But if I added these two angles together, what would I get? What is it? 180, right? Because they're a linear pair. So if I think about it, wouldn't it cut it off proportionally? And so the best way to think about this is, yes, the tangent intersects at exactly one point on this circle, okay? But, right, for like a very small moment, that point that it intersects kind of acts like an inscribed circle, or inscribed angle, just with one of the chords' length is 0. Okay? So the same thing's going to be true, right? Because we said with an inscribed angle, right, the angle measure is half of its intercepted arc. It's going to be the same exact case in this one. So in this case, I know that the measure of angle BCE is going to equal 1/2 the measure of arc BC. Okay? Another way of saying that, right, is that measure of arc BC is twice the measure of angle BCE. Okay? And likewise, on the opposite side, we know that the measure of angle BCD is going to be equal to half measure of arc BFC. Okay. And likewise, measure of arc BFC is going to be double measure of angle BCD. Now again, just understand that these two essentially are saying the same thing and these two are essentially saying the same thing. It's just depending on context, one might be easier to use when trying to solve for one of these types of angles. Okay? Are we okay so far? Yeah? Okay. All right. Moving on. So again, essentially when we think about circles intersecting on, or sorry, when we think about lines intersecting on the circle, their point of intersection is on the circle, right? The one thing that we want to make sure that we understand is that when I see the word on, or if I see that it is on, right? Think angle is equal to half arc. Okay? Every time. Okay? Doesn't matter what type of lines are intersecting on that circle. It could be two radii. It doesn't matter. Okay? Any single time that we have two segments intersecting on the circle, the angle that's created, right, is exactly half of the intercepted arc. Okay? So again, this isn't going to be any different, essentially, the way that we kind of solve these. This certainly isn't going to be any different than the way that you did with inscribed angles. So please go ahead and, if you have it, get out this example, the example problems, and we're going to do a couple. So I'm going to put some points on here just to kind of help clarify some things. So I'm going to call this point R. Oh, that looks terrible. A little bit. I'm going to call this point R. I'm going to call this point Q. Okay. And it's just going to help us with trying to get familiarize ourselves with using the correct terminology. Okay. So, what I'm asked to find here is I'm asked to find measure of angle VUT. Okay, that's the question that I'm trying to solve. Okay, what I'm given, right? I'm given measure of arc UQT is equal to 232 degrees. Now I'm going to show you two different ways to go ahead and do this. Just because, I mean, and that's kind of the thing that hopefully you're starting to see when it comes to circles. Like, there's way more than one way to approach a problem. Okay? The more complicated the problem is, the more possible ways there are to solve it. So I'm going to do it one way. It does not necessarily mean that you have to do it that way. Okay? It's all about problem solving. If you see something that you can apply it. Okay? As long as we stick to our rules, there's no wrong way to solve the problem. Okay? So, I'm going to make this a little bit thinner. If I know that the measure of arc UQT, right, this guy right here, is 232, okay, I can actually figure out what the measure of arc UT is. Okay? And I do that by going, hey, you know what? If I add these two arcs together, what do I get? Well, if I add measure of arc UT plus measure of arc UQT, what do I get? $360. Right? I get 360. Okay, because they make up the whole circle. Well, I already know what UQT is. It's 232 degrees. So if I wanted to find what measure of arc UT is, all I do is subtract 232. And I get measure of arc UT is equal to, what is that? 138? Is that right? That doesn't sound right. What? 128, thank you. 128 degrees. Okay? So now if I know that this angle is 128 degrees, okay, if I'm trying to solve for measure of angle VUT, right, applying that formula or that theorem that we just taught or learned, and I always recommend using the half, because the half is just, it keeps it consistent. You don't try to think double, so on and so forth. Just stick with half, okay? So I know that the measure of angle V UT, right, is equal to exactly half the measure of arc UT. Okay? So if I know the measure of arc UT is 128, right, I'm just going to now substitute that in. Okay? So I know measure of angle VUT is exactly 1/2 of 128, which means measure of angle VUT is what? 64 degrees. Okay? That tells me that this angle right here is 64 degrees. Okay? And so that's one way of doing it. The other way, the alternative way, or another possible way that I could have done this, I should say, is I could have gone ahead and gone, well, you know what? Right? I know that this angle is 200, or this arc is 232 degrees. I know the measure of angle RUT is exactly 1/2 measure of arc UQT. Okay? Which means measure of angle RUT is 1/2 232, which is equal to, what's half of 232? 116? Yep, 116. Okay? So I know if this angle is 116, and I know that the measure of angle RUT plus the measure of angle VUT is equal to 180 degrees, because they are a linear pair, I could just substitute it in here. And I could say, well, that means 116 plus measure of angle VUT is 180. Subtract 116. And I still get measure of angle VUT is equal to 64. Okay? So again, two very different approaches for how to do this, both ending with the exact same solution. Okay? Whichever way you prefer, whichever way you see, do it that way. Okay? So from here on out, I'm just going to do each of these problems one way, but I just really want to emphasize more than one way to do these. Okay? All right. Number 2 is a little bit easier. Okay? Number 2, right? I'm asked to find, right, the measure of arc BC. Okay? What I'm given is I know that the measure, oh good Lord, how are we going to do this? I know that the measure of angle BCD is equal to 40 degrees. Okay. Applying the secant tangent intersection theorem, I know that the measure of angle BCD is exactly 1/2 measure of arc BC. Okay. Now, since I know a measure of angle BCD is 40, I know 40 is equal to 1/2 measure of arc BC. All I'm going to do is I'm going to multiply both sides by 2. That's going to cancel out. Multiply this by 2. And I get that measure of arc BC is equal to 80 degrees. Okay. Very simple. Any questions so far? Okay. We'll do 2 more problems. All right. These ones are a little bit trickier because now I'm asked to solve for x. Okay? Can you shut that door, Logan? So, before we really approach this problem, again, I'm going to put some new points on here. Okay. Just to kind of make it easier for us to kind of identify what parts we know. Okay. So before I really go anywhere, I want to just write out what I know. Well, I know that the measure of arc SPT is equal to 33x minus 11. Okay. I also know that the measure of angle RST, oops, I almost made that an arc, is equal to 5x minus 8. Okay. Now there are a couple different ways to approach this. Actually, there's a lot. Now, I could figure out what measure of angle QST is and then try to use the linear pair formula like we did in the first one. But if I look at arc SPT, if I tried thinking about multiplying this by a half, I'm going to get some ugly fractions. Okay? And I'd like to keep this as whole as possible. It just makes things easier. Okay? So what I'm going to do is instead is I'm going to find the measure of this arc and use the idea, right, that measure of arc SPT plus the measure of arc ST is equal to 360 degrees. Okay? So you already know SPT, right, is 3x minus 11. So let's find measure of arc ST. Okay? Well, what I also know about angle RST is that it is equal to exactly 1/2 of measure of arc ST. Okay. So since I know measure of angle RST is 5x minus 8, I know that's exactly 1/2 of arc ST. Okay. So in order to find ST, I'm going to multiply both sides by 2. Now remember, when I do this, right, a lot of you guys have a common tendency to go ahead and just multiply one of the values. Remember, I'm multiplying the entire thing side by 2, so I do have to distribute this 2. And so I get that the measure of arc ST is equal to 10x minus 16. Okay. Now, since I know measure of arc SPT and I know the measure of arc ST, I'm going to plug them both into this equation. Okay? So, I know that SPT is 33x minus 11. So I get 33x minus 11, the whole quantity, plus ST, which is 10x minus 16. If I add those together, I get 360. Okay? Uh-oh. Oh, no. Oh, don't start. Oh, don't do this to me. Are you guys... You saw that, right? What happened? Where's all of my writing? Where'd it go? All right, it's back. All right. Let's just power through this problem as fast as we can go, please. This is awkward. All right. So now when I combine like terms, all right, on the left-hand side, I should get 43x minus 27 is equal to 360. Add 27, add 27. You get 43x is equal to, what's that, 387. Okay. Divide both sides by 43. And I get x is equal to, what's that, 9? Can someone do that calculation really quickly? Nine? Okay. So I have x is equal to 9. Yay! But we still need to check. Okay? So anytime that I'm just solving for x and I've gone through this whole complicated process, it's definitely recommended to check and make sure. Okay? So to check, I'm going to do a couple of things. First, I'm going to plug it back into both SPT and ST. Okay, so I'm going to plug this back into here and back into here. Okay, and I should see that if I do add those two values together, I should get 360 degrees. Okay, likewise, I'm also going to plug it back into our ST to see if it's half of what I get for the intercepted arc. So I'm going to check it in a couple different facilities. Okay, checking this. Okay. I know the measure of arc, SPT, is going to equal 33 times 9 minus 11, which is going to give me, boy, I cannot do that off the top of my head. Oh my goodness. 297, so it's 297 minus and my screen froze. My iPad froze. All right, we're going to go ahead and stop there. I'm going to post the solutions to these so you guys can see. We only had one more problem to do, and it was very similar to the first one, or to problem number 2 that we did. Just involves X. I do have my video from last year on there that details the last 2 problems if you need to see the explanation. Just so you know, okay? So I'm gonna go ahead and post this one anyway, because why not? But you can watch either video, whichever one needs the help, or needs your help, or whichever one will help, and you can. The answers are already posted on Canvas. Okay. All right.